Welcome back to Daily AI News at Let's Data Science. It's 2026-0601. Today, we're diving into some pivotal developments from the future of machine intelligence to major product launches. Let's get to it. Our top story today: NVIDIA has unveiled RTX Spark, a new ARM based superchip designed to reinvent the Windows PC for what CEO Jensen Huang calls the era of personal AI agents. Announced at GTC Taipei and in coordinated posts with Microsoft, RTX Spark combines up to 6,144 Blackwell CUDA cores with a 20-core ARM-based NVIDIA Grace CPU, co-developed with MediaTek. The chip supports up to 128 gigabytes of unified memory and delivers roughly 1 petaflop of AI performance. NVIDIA says the platform can run 120 billion parameter models locally with context windows of up to 1 million tokens. That's a dramatic shift in the baseline capability of a consumer Windows machine. The RTX Spark integrates CUDA, RTX graphics, FP4 precision, TensorRT, OptiX, and a custom NVLink chip-to-chip interconnect between the Grace CPU and the Blackwell GPU cluster. Microsoft is optimizing Windows on ARM to support this architecture, including compatibility layers for legacy x86 applications. OEM support is broad. NVIDIA and Microsoft list ASUS, Dell, HP, Lenovo, Microsoft Surface, and MSI as launch partners, with Acer and Gigabyte to follow. Devices are expected this fall. From a practitioner standpoint, the key innovation is the 128 gigabytes of unified memory. Large unified memory pools reduce friction when experimenting with long context LLMs, multimodal pipelines, and persistent agent workflows. Instead of orchestrating CPU RAM and discrete GPU VRAM, developers can allocate across a shared memory space. That said, early adoption will hinge on toolchain maturity. PyTorch, TensorFlow, ONX Runtime, and TensorRT will need to expose optimized paths for the Blackwell GPU on Windows on ARM. Emulation for legacy x86 applications remains an engineering trade-off that could influence real-world productivity. Closely tied to RTX Spark is Microsoft's announcement of the Surface Laptop Ultra, a 15-inch flagship device powered by the same superchip. According to Microsoft's Surface blog and coverage from The Verge and Engadget, the Surface Laptop Ultra can include up to 6,144 Blackwell RTX cores, up to 20 ARM CPU cores, and up to 128 gigabytes of unified memory. Microsoft says the device can run models up to 120 billion parameters locally. The Laptop Ultra features a 15-inch mini LED PixelSense Ultra display with 2,000 nits of peak HDR brightness, which Microsoft describes as the brightest display it has shipped. NVIDIA Senior Vice President Jeff Fisher said, "NVIDIA and Microsoft share a vision that agents are the future of personal computing." Microsoft Surface Corporate Vice President Andrew Hill called it the most powerful thing we've ever made. For developers building local AI workflows, this signals a credible high-end Windows on ARM workstation. But pricing, battery life under sustained AI workloads, and CUDA ecosystem stability will determine whether it becomes a mainstream developer platform or a niche Halo device. While NVIDIA is pushing into the PC, it's also scaling up aggressively in the data center. The company announced that its Vera Rubin platform is ramping into full production. Vera Rubin is described as a pod-scale AI factory architecture that unifies Vera Rubin NVL72 systems, the Vera CPU, Bluefield 4 STX storage, and Spectrum-X Ethernet photonics. NVIDIA claims a 10x agent throughput improvement versus the prior Grace Blackwell platform. Manufacturing is reportedly underway across more than 350 factories in 30 countries, with 150 partners in Taiwan alone. OEMs and infrastructure partners named in coverage include Dell Technologies, HPE, Lenovo, and Supermicro. In parallel, NVIDIA has begun shipping its standalone Vera CPU systems to early customers. PCMag and Datacenter.news report that NVIDIA executive Ian Buck personally delivered Vera systems to Anthropic, OpenAI, SpaceX AI, and Oracle Cloud Infrastructure. The Vera CPU features 88 Olympus cores and up to 1.2 terabytes per second of memory bandwidth. NVIDIA says per-core performance can be 50% faster under full load than prior designs. Yahoo Finance reports that Oracle plans to deploy hundreds of thousands of Vera CPUs beginning in 2026. For ML infrastructure teams, this underscores a shift toward tightly co-designed CPU, GPU, networking, and photonics stacks. Evaluating such systems requires system-level benchmarking under representative agentic and reinforcement learning workloads, not isolated micro-benchmarks. Now, turning to policy. The U.S. Department of Commerce has clarified export license requirements for advanced AI chips. According to Reuters reporters Karen Freifeld and Fanny Potkin, the new guidance makes clear that export license requirements apply to entities headquartered in China, even if those entities operate outside China. The guidance covers leading chips including NVIDIA's Blackwell and Rubin families and AMD's MI350X. A Bureau of Industry and Security spokesperson told Reuters, BIS issued guidance clarifying export license requirements that have been in place since 2023. One unnamed industry source estimated that hundreds of thousands of advanced chips may have moved through the prior regulatory gap. Importantly, the guidance does not require data centers to stop using already deployed equipment. For procurement and infrastructure teams, this raises compliance complexity and potential lead time friction for high-end accelerator sourcing, particularly for multinational organizations. Now, for a few other key updates in our lightning round. At Computex, Intel revealed more details about its next-generation data center GPU, Crescent Island, built on the Xe3P architecture. Tom's Hardware reports the reference design is a 350-watt PCIe add-in card using LPDDR5X memory instead of HBM or GDDR. The reference configuration includes 160 gigabytes of LPDDR5X, with partner designs scaling up to 480 gigabytes. Leaked analysis suggests a 640-bit bus, delivering roughly 684 gigabytes per second of bandwidth using 10.7 gigabits per second LPDDR5X modules. This capacity-first design could simplify model residency for inference workloads, but trades off peak bandwidth versus HBM-based accelerators. NVIDIA also debuted its N1 and N1X laptop system on chips at Computex. According to Tom's Hardware and Gizmodo, the top-end N1X features up to 20 ARM CPU cores and 6,144 CUDA cores, with support for up to 128 gigabytes of LPDDR5X memory. The standard N1 appears in 10 and 12 core configurations with up to 64 gigabytes of memory. These chips pair ARM CPUs with Blackwell GPUs and are tightly linked to Windows on ARM adoption. Finally, a Financial Times report summarized by India Today says Iranian-linked operators have used ChatGPT and Google's Gemini to develop malware and multilingual phishing campaigns targeting the United States and Israel. Google reportedly detected the state-linked group APT42 using Gemini in late February. The United Arab Emirates said it faces more than 500,000 cyber attacks daily, some reportedly assisted by AI tools. For security teams, this reinforces the reality that accessible large language models are lowering the barrier for high-volume social engineering and rapid malware prototyping. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in, stay curious, and we'll be back tomorrow with the latest in AI.